In section 3.6, we will be solving polynomial inequalities. We are to solve and graph the solution set on a real number line of 2x squared plus x greater than 15. The first thing I'm going to need to do is I'm going to need to subtract 15 from both sides. I have 2x squared plus x minus 15 greater than 0. Now, once you get it set equal to 0, we will solve this inequality. We will take the polynomial and set it equal to 0 and solve for x. That's the first thing we'll do. So let's factor this. I cannot take out a GCF. So factors of 2 would be 2 and 1x on the front. Signs are going to be different, negative at the back. Factors of 15, 1 and 15, 3 and 5. Now, I've got to fix this so that when I foil the two binomials, I go back and get what I started with. All right, I'm going to put my 3 here and my 5 here. You could test that out. 2x times 1x is 2x squared. The outside gives me 6x. The inside's negative 5x. 6 minus 5x. 6x minus 5x gives me my positive 1, and I still get my negative 15 on the back. So I have factored correctly. Now, setting each one of those equal to 0, I will find my critical numbers. Add 5 to both sides. I have 2x equals to 5. Divide both sides by 2. So x equals 2, 5 halves. Subtract 3 from both sides. I get x equals 2, negative 3. So these are my critical numbers. These are the numbers that I will use to separate my graph. So I'm going to draw my number line, keeping and reminding ourselves that 0's in the middle. 5 halves, that's 2.5. If you punch it in your calculator, 5 divided by 2, that's 2.5. So I'm out here 1, 2, here's 3. So I'm somewhere about right here is 2.5. I'm going to draw a dotted line at 2.5. Kind of dividing my number line into intervals. Then I have negative 3 to the left out here, and I'm going to draw my dotted line here. So I have 3 intervals on my graph. I have everything less than negative 3, everything in between negative 3 and 2.5, and then everything greater than 2.5. Now, my original problem said greater than 0. So I'm looking for the intervals that represent a positive value. That's what I'm looking for. Greater than 0 says I'm looking for positive intervals. Okay? So what I'm going to do is you're going to take the final factored form, and I'm going to place those two binomials right over here to the side, 2x minus 5 and x plus 3. So we're going to pick test numbers in all 3 of these intervals, and we're going to test them. So the test number that I'm going to pick for this middle interval is 0. Anytime I can use 0, I use 0. To pick a number greater than 2.5, I'm going to pick 3. To pick a number less than negative 3, I'm going to pick negative 4. So these numbers that I have circled are my test numbers. These numbers that I'm putting in the squares are my critical numbers. Now, the way you test them is you plug them into the two binomials, because that would be just like plugging them into the trinomial here. So if we plug in negative 4, 2 times negative 4 is negative 8. Negative 8 and negative 5 would give me negative 13. I'm just going to put a negative sign. This is my sign chart that I'm creating, and I'm just worried about the sign. So I get negative 13 here. If I plug in a negative here, negative 4, what's negative 4 plus 3? That's negative. Now, these two binomials are multiplied together. That's what I'm going to do with these two signs. What's a negative times a negative? Well, that gives me a positive. Therefore, this interval is a positive. That is a good interval. So everything less than negative 3 will be in the final answer. That if one number in an interval satisfies that region, then every number in that region is also a solution. So since negative 4 satisfies since I got a positive, everything in this region will satisfy the final answer. Test 0. If you plug in 0 here, 2 times 0 is 0, minus 5 would give me a negative. If I plug in 0 here, 0 plus 3 is positive 3. That's a positive. But what's a negative times a positive? A negative. So this region is not good. We don't want negative numbers. We want numbers greater than 0, and that's my positives. Now plugging in positive 3. If I plug in 3 into the 2x minus 5, 3 times 2 is 6, minus 5 gives me positive. If I plug in 3 here, 3 plus 3 is positive 6, that's positive. And what's a positive times a positive? A positive. So that's a good region. So this is another answer. All of this greater than 2.5 is also an answer. So if I had to write my final answer, I'm going to tear out this sheet and move it up. So if I had to write my final answer, it would be from negative infinity to negative 3 union 2.5 to positive infinity. That would be my final answer because this region gave me a positive, everything less than negative 3. This region, everything greater than 2.5, gave me a positive region. We wanted positive because the original problem had greater than 0. Now it's just a greater than, it's not an equal to, so notice I used parentheses. Let me use parentheses on my graph. So my final answer would be negative 3 parentheses, shading everything this way, and 2.5 parentheses and shade everything that way. So that would be my final answer of my graph. This would be my final answer in interval notation. If you're asked to put your final answer in interval notation, this would be your graph. Now you do need a union in between because it is everything in this interval plus everything in this interval.